Hi there. One of the first things we get to in geometry very often is proofs, and really in the entire course of geometry you'll see more proofs than usually in other math classes, just because it's a kind of a convenient place to do it. But proofs really go into all branches of math, because in math nothing that you use, nothing that's called a theorem or a postulate, or well, nothing that's called a theorem or a corollary or anything like that, most of those things have been proven before we're allowed to use them. So that's even true in algebra and trig and anything else. But we just have so many of them in geometry, we usually start here with geometry. Now, when we start looking at proofs, very often we look at algebraic proofs to begin. So I just wanted to go ahead and go through this worksheet on algebraic proofs with you. There's a couple of things I don't love about this worksheet, but we'll talk about those as we get to them. Still, you can get a lot out of this in terms of basically how do I do a proof, how do these properties work. So first up here we have state the property that justifies each statement. Okay, now, if 80 equals m, measure of angle A, and then the little m stands for measure, and then the measure of angle A equals 80, this is like saying here's one step in your proof, and this is the next step. We start with this, and we conclude this. Now, all that's changed between those, and that's very often what you're looking at, is what's different. All that's changed is the order of what's on which side of the equal sign. That's symmetric property. The symmetric property basically implies that there's a big line of symmetry down the middle of an equal sign. And so if you just flip-flop which is on which side, what information is on which side of the equal sign, forgive the bell, then you are using the symmetric property. Because if two things are equal, they're still equal no matter which one you put on which side. Next, we have two statements that we put together to make a third statement. Now, a big clue when you see two statements and you're putting them together to get a third statement, that's probably going to be either transitive or substitution, because those are the two properties where that happens the most. Now, transitive property, you have to specifically see that two different things are equal to the same thing. In other words, one side of each of your two equations you're putting together has to be completely the same. So RS is equal to this, and YP is equal to this. Two different things are both equal to TU. So then we're able to say, well, let's just take TU out of the picture and say they're equal to each other. That's how transitive property works. It's kind of taking out the middleman. But you do need to see in your first two equations that one side of each of them matches. That's important. Next we have if 7x equals 28, then x equals 4. So thinking about what changes from here to here, you would think about what would I do if I looked at this? What would I do to solve this? Well, I would divide by 7, and that's exactly what's happened. If I divide by 7 on both sides, then I get x equals 4. Dividing by 7 on both sides means I'm using the division property of equality. Sometimes we abbreviate that POE, property of equality. We usually like to state property of equality just so that we don't confuse it with something else. Number 4, okay, we have if VR plus TY equals EN plus TY, then VR is equal to EN. Remember, these are lengths. If you don't see a symbol over the top of the segment name, that means if the length of segment VR plus the length of segment TY, etc. All right, so again, the goal is to see what is different from here, which is our hypothesis, over to here. What has changed? And you see the VR here, VR, EN, EN. What has changed is that I used to have plus TY and plus TY. And in my conclusion, I don't have it anymore. If you're removing something, very often that's subtraction. And sure enough, that's what would work. If I subtracted TY from both sides, then I would get what you see there. And so that's why subtraction property of equality is correct. Finally, here's another case where I have two equations and I'm putting them together to make a third equation. So 1 and 2 equations put together in my hypothesis, or I'm given two different equations in my hypothesis, and I'm putting them together into a third equation in my conclusion. That's a clue that you're looking at either transitive or transitive or substitution. Now this one, you could possibly make a case for substitution, but to me, I like to use transitive anytime I have what I told you about up here, And that is, you have two different equations where something is equal to the same thing. In this case, measure of angle 1 equals 30. Measure of angle 1 also equals measure of angle 2. So both of these things are equal to the measure of angle 1. It's in both equations. It's alone on one side in each equation. So the entire side of this equation matches an entire side of this equation, and that's when I can take out that middleman and say, okay, well, if they equal the same thing, then they must equal each other. So that is also transitive property. All right, so complete the following proof. Now, this particular worksheet, one thing I don't like about it is that it sometimes shows sort of intermediate steps that we don't always show in a proof. So let me show you what I mean on that. Starting at the front, we've got the given information here. And you always want to start out by looking at your given information and saying, do I see that in the proof at all? This is partially filled out, so do I see it already in there? And I do. It's right here. So that's going to be given. Given just means this is what I was given to go on. I don't have to justify knowing it because you told me it. You told me this was true. Now the next step here, you can see that we are subtracting 2x from both sides. This worksheet's trying to be helpful and show me the subtraction process. Usually you don't see the actual process of doing the work to both sides. You see basically you see the reason, and the reason tells you what happened. In other words, I would see the word subtraction property of equality, and that would tell me I subtracted. Or I would be the one telling, oh, I subtracted, so I'm going to say subtraction property of equality. Here, we're going to do it up here. We're going to say subtraction property of equality, where we're seeing the work. And this is just me knowing from the way they have this laid out what they are expecting of me. And then we're actually simplifying here, and they're calling that substitution property. I could also see the simplifying step. Sometimes people just say combine like terms or simplify. Very often we don't even show the simplifying step because we would go right from step A to step C, which is 6x minus 5 equals 1. And what's happened from step A to step C is that I have subtracted 2x from both sides. So if I went straight from here to here, I would put subtraction property over here. But they're just doing the same thing in 2 steps. Showing the work and calling that subtraction property of equality, and then simplifying and calling that substitution. Now the next step says I'm going to use the addition property. So again, you know how to solve an equation, so think about what would you add to both sides to solve this. Why would you want to add something to both sides? Clearly to get rid of something on one side of an equation. So I would want to add 5 to both sides. And again, not always in proofs, but in this one they actually want me to show the work, because if, in most proofs, if I add 5 to both sides, the next thing you would see is this. But here we're actually showing the work. So let's go ahead and do that. We'll go ahead and follow the format they have laid out for us for this proof. And I add 5 to both sides, addition property of equality. And then that gives me 6x equals 6. And again, that's really simplifying. I'd rather write simplifying. They have been writing substitution. I'm just going to write simplify. Now what happens next to both sides? We have division. We're dividing both sides by 6, so that's division property of equality. And finally that gives me x equals 1. Now remember, and that's simply simplifying. Is all of this happening here. Simplify, or they would probably call it substitution, but I'm fine with just saying simplify. Really depends on what your teacher says. Some teachers are very, very formal about proofs. Some teachers are very, very casual about proofs. And most teachers are more formal sometimes than they are other times. One thing that is always true is the very last step on the statement side is going to be whatever you were asked to prove. Okay? Because if you've proven it, then you've arrived at your destination. And if you haven't proven it, if you can't say it, then you're not done with the proof yet. So if somebody asks me to prove something, as soon as I say, aha, see, this is true, then I'm done. So the last step on statements is always going to be the same thing you were asked to prove. Now be careful about hearing that the wrong way. You will never use the word prove like we use the word given in a proof. You will never go, oh, x equals 1 and go over here and write the word prove, because the word prove does not prove anything. We will never write the word prove as one of our statements or as one of our reasons, so please do not do that. We do write the word given because it explains how I know something. The word prove does not explain how I know something. Okay? So in terms of the reason for this, it always comes from what has been happening before this. This is my evidence. I say, here's my evidence on why this is true, and I have a final piece of evidence. And in this case, it's because I simplified this statement to get this. All right, I'm going to go ahead and break the video here and do a few more problems in my next video. If you want to go ahead and pick up on that, please feel free. Please remember also, you can always pause, rewind, pause and do some work, pause and ask yourself, do I know what's going to happen next? Do I think I know what she's going to do next? Use math videos very interactively, and they will give you a much bigger benefit. All right, it's been great. Thanks.